presented by Dr. Halyna Krechkovska.
Dear colleagues, I am Halyna Krechkovska. I am from Karpenko Physico-Mechanical Institute of the National Academy of Science of Ukraine. In my report, I am going to discuss fractographic science of operation degradation of heat-resistant steel for estimating its actual structural mechanical state. The presentation includes introduction, object of research, methods, result and discussion, and conclusions. I am going to discuss structural science of steels, mechanical testing, fractographic science of operated steel, and dependence between the fractographic and mechanical indicators. Thermal power plants are very important components of the energy sector of any country. Ensuring their safe of their operation is a crucial task. Thermal power plants include a network of steam pipelines made of heat-resistant steels. Failures in the power industry is often caused by steel degradation during its long-term operation. Important factor influencing the degradation of low-alloyed heat-resistant steels of main steam pipeline of the thermal power plant includes high operation temperature, corrosive hydrogenated technological environment, cyclic and static loads in various components, and shutdowns of the technological process. The consequences of their impact are manifested by transformation of the structural phase of steels and change of the mechanical characteristics such as strength and plasticity, impact toughness, fracture toughness, and fatigue crack grow resistant. Shutdowns of the technological process significantly influence the structural mechanical state of the metal, creating additional stresses in the pipe cross-section. The complex of the listed operation factors promotes the occurrence of critical damages in the structural state. Their main steam pipelines are operated under temperature 540 degrees Celsius and pressure up to 24 megapascal. In this work, we investigated long-term operated heat-resistant steels. Chemical composition of the steels is presented in the table. The metal from two power unit was selected similar operation time, but different number of shutdown. The research aims at analyzing the fracture surface of steel specimen after mechanical testing and also identifying and quantifying fractographic signs of the steel operational degradation. To assess the operated steels are following characteristics we used: impact toughness, fracture toughness, loading by three-point bending, and fatigue fracture growth resistance. The threshold values of stress intensity factor range and delta KTH effective and delta KT8. The structural science of the operated metal and fractography peculiarities of the tested specimens were evaluated using scanning electron microscope. Grain science and carbide science in the structural science are quantitative structural indicators that determine its mechanical properties. It was shown in our previous research that high temperature operation result in redistribution carbon and alloying elements in the steel with precipitation and coagulation carbide along the grain boundaries. Coarse carbide at the grain boundaries have weak cohesion with the matrix, which makes easier their decohesion and formation pores around them. This reduces cohesion adjacent grain boundaries and formation pores around them. Further formation of a system of microcrack. Further formation of microcrack significantly affect of the strength of materials. On the slide representation, some metallographic features namely size distribution grains and carbides across the pipe wall. Yes. There are smallest size carbides and grains is the center cross pipe wall. Structural change of the most pronounced in the vicinity of the pipe outer surface and the more shutdowns of the technological process. Mechanical testing revealed a clear decrease of all considered characteristics in the steel as a result of the long-term operation. The more several operation condition, the more shutdown, the lower mechanical characteristic of the steel despite almost the same operation time. In this slide, we present fractographic feature of degradation of heat-resistant steel and a different number of shutdowns after impact tested. Here you can see fractographic signs of decohesion weakening at the grain boundaries. A number of the intergranular facets indicated by arrows is larger for a metal subjected to more shutdowns of the technological process. Not all these intergranular facets occurred during the steel operation on the steam operation due to creep. However, it's clear evidence that in the intergranular cohesive strength of the steel decrease due to its operation on the steam pipeline of the thermal power plant. A similar result we obtained for fracture toughness test as is a previous case. The part of intergranular cohesive intergranular fragments was bigger in the metal operated with more shutdown of power unit. For fatigue crack growth resistant test, the pre-fracture zone at the crack tip is smaller than the fracture toughness test. The intergranular fragment found at the fracture surface were not only a result of the bone weakening between adjacent grains, but also a sign of intergranular cracking, cracking caused by steel operation. Fatigue fracture surfaces are formed as a result of deformation plasticity process is a zone deformation comparable with the grain signs. As a result, transformation fracture occurs in the initial stage of steel and intergranular fragments for operated metal. The figure presentation a comparison of the sensitivity of the proposed parameter S, the different four types of mechanical tests, this fatigue test, fracture test, and impact test. Past intergranular facets is larger after impact test. The different parameters S for the steel with different shutdowns is more pronounced. We obtained dependence between mechanical KCV operation to KCV initial and fractographic indicators. Fractographic indicators is part of intergranular facets. It depicts a change of structural and mechanical state of the steel depending on a number of shutdowns and also this the part of intergranular fragments is proposed to use as fractographic indicator of the operational degradation of heat-resistant steel. This conclude quantitative structural indicators that determine the mechanical properties of steel, heat-resistant steel long-term operated on the main steam pipeline of the thermal power plant include of the size of grain and carbides in its structure, which increases with more shutdowns of power units. The fractographic signs of cogagent weakening between the adjacent grains is in operated heat-resistant steel is fragments of international fracture on the fracture surface of the heat power equipment element, and also on the fracture surface of operated steel specimens after impact testing, fracture toughness testing, and fatigue testing. Based on fractographic research of the long-term operated steel, the area of intergranular fragments on the unit area of the fracture surface is proposed as a quantitative fractographic indicator of change in its structural and mechanical state due to degradation. The mechanical characteristic of brittle fracture resistance of the steel are consistent with the proposed fractographic indicators of the metal state. Thank you for your attention.
Thank you for the presentation.